During this session, Pesticide Application Procedures, we'll talk about different application methods and the importance of measuring the application site and pesticides correctly. It will provide tips on a simple approach to calibration story problems, similar to the style of story problems you'll see in the National Pesticide Applicator Core exam. There are many different application methods, as you'll see here in the photos in the list. A few examples are broadcast applications, air blast sprayers. Some people inject pesticides directly into the soil, and you've probably applied pesticides with a handheld or backpack sprayer. In the bottom left corner is a cut stump treatment. This is a common method for conservation crews working on invasive plant and weed control programs. You see the person has cut the stump and is brushing the pesticide into the stump. There are several factors that can impact the amount of product that's applied to the site. These include spray pressure, nozzle height, and tank capacity. The three main variables when applying through boom sprayers are travel speed, nozzle flow rate, and the width sprayed per nozzle. You might hear that some growers or employers are performing all of the calibration activities for their employees. They're filling up the spray tanks and then asking their employees to simply go out and apply the pesticide to the treatment site. Their intentions are probably good. They want to make sure that everything's mixed and operating correctly. And maybe it's a concern about an employee's ability to interpret the label information that's only written in English. However, keep in mind that each person is different. While some of these things can be controlled on tractors, handheld or backpack sprayer applications can be trickier due to walking speed and a person's height. In addition to the previous factors, there are several other things that can impact the amount of pesticide applied to a site. The amount of pesticide you apply can be impacted by the type and speed of your equipment. As pesticide manufacturers develop products requiring smaller weights or volumes to treat larger areas, the accurate measurement tools are essential. I mentioned earlier that there are some growers who calibrate, mix, and load the pesticides into the tanks for their handler employees to apply. Others rely on employees who have been with your operations for years to mix and load the pesticides. This might be a foreman or supervisor who also takes on the role of showing new hires how to measure, mix, and load. This is perfectly acceptable. It just might help to remind them to address the different ways or devices used to measure liquid and dry products. I think it gets tricky because when you're following a recipe to cook a dish, you measure the liquids and dry ingredients in the same measuring cups and utensils. For example, a recipe might call for a teaspoon of salt, a tablespoon of vanilla, a cup of water, and 2 cups of flour. That concept doesn't transfer over to the tank of mixing pesticides. Question: what's the most accurate way to measure dry pesticide products? Answer: use a scale and weigh them. Sometimes you'll receive measuring devices with the products you purchased. They might be attached to the container, as shown underneath the cap of the water-soluble granule pesticide container shown in the top corner of the slide. The manufacturer might include measuring devices in the box of a shipment of several containers of the same product. Use the containers provided even if you've purchased the same product before and still have the older measuring devices. It's possible the size, shape, or weight of the granules have changed, and the manufacturer has provided new measuring devices to accommodate the change to make it easier for you. Manufacturers may package measuring devices with the dry product container to make it easier for you to get an accurate measurement. Only use the measuring device that was sent with the product. Don't keep the measuring cup to use with other products or with the same products you receive in the next order. A manufacturer may change the formulation slightly. The label and packaging might appear to be the same, but the formulation or product size, like a granular product, could be slightly different. Again, that could impact your ability to effectively control the pest or result in an over-application of the product. Some people use this type of measuring device, tip and pour style. Have any of you used this type of device before? What did you think? Was it easy or tricky? Each person has their own preference. Some people really like this type of liquid measuring device, and others get frustrated as they tip it forward and realize they measured out a little too much. Then they tip it back and realize they don't have enough. If it works well for you, great. If it doesn't, search for a device you can use comfortably and correctly. As mentioned earlier, it's also important to accurately measure the site you're going to be treating. You can determine the size of the area you're going to treat by using Google Maps. First, zoom in on the area to be treated. Then right-click on a corner of the area. Select Measure Distance from the drop-down menu. Next, continue to add points by right-clicking, and each time select Measure Distance. When an area is encircled, the area is provided in square feet. You'll sometimes need to convert the number of square feet you found on Google Maps into the number of acres, especially if you're treating a larger area. Remember this conversion factor. 1 acre equals 43,560 square feet. All you need to do to complete this conversion is to divide the number of square feet in the area to be treated by our acre conversion factor. The plot we're looking at here is 667,768 square feet. So to get the number of acres, we'll divide that number by 43,560, which is the number of square feet in 1 acre. This gives us a result of 15.32 acres total. This video includes 2 sections. The first section is the one we'll watch. It focuses on calibrating for an application to a small area, such as a lawn or garden, using a backpack sprayer. I've included the link to the video so you can watch the second section if you're interested in learning how to calibrate for an application to a much larger area, such as a field.
Backpack sprayers offer a convenient, cost-effective way to apply pesticides at your farm, in your garden, or on your lawn. As with the use of any spray equipment, calibration is essential to getting the treatment applied correctly. We're going to show you the basics of 2 methods to use for calibrating backpacks. One for treating small land areas such as lawns and gardens, and the other method for agricultural applications. Before we conduct the calibration, keep in mind that there are many techniques for backpack sprayer application. One of the most popular methods is by holding the application wand steady and off to one side, about knee-high, while moving forward. Another common method is to swing the wand back and forth in a pendulum motion while you walk. Either application method is acceptable. Just be sure to remain consistent from your calibration tests to your actual application. If possible, do a small test with water on an area like blacktop so that you can see what type of nozzle pattern is being applied, and so you can get a relatively accurate sense of how to cover a particular area evenly. Now to calibration. Let's start with the method for land areas like turf, planting beds, or gardens. This method is appropriate when you're using a pesticide that's applied on the basis of 1,000 square feet. An example from a pesticide label would be, apply this product at the rate of 2 ounces per 1,000 square feet. Step 1. On a surface similar to the treatment area, stake out a plot of 1,000 square feet. Here we'll be doing a plot of 50 feet by 20 feet. Step 2. Fill the sprayer tank halfway with water. Never calibrate with actual product, so you'll not need to worry about exposure to hazardous products while you're conducting the test. Step 3. Record the amount of time it takes to accomplish a uniform coverage of the 50 by 20 foot plot. Make sure you're using the same operating pressure and walking speed throughout. If possible, repeat the process 2 or 3 times and use the average time. Step 4. Spray directly into a container. preferably one marked with fluid ounce measurements, using the same pressure and for the same amount of time it took to spray the calibration plot. This will tell you how many ounces of product are being applied in that 1,000 square foot area. Step 5. With basic math proportions, you can then determine how much material you'll need to treat any size area. Let's try an example. Your lawn is 40 feet by 65 feet, or a total of 2,600 square feet. The label application rate is for 2 ounces of product for every 1,000 square feet. Your test plot time for 1,000 square feet is 80 seconds. And the amount of water collected in your 80-second test is 57 ounces. Therefore, your calibrated sprayer output is 57 ounces per 1,000 square feet. Now, in order to determine the total amount of spray solution needed, we'll use the following formula and cross-multiply. The math works like this. 1,000 times X equals 57 times 2,600. X equals 148,200 divided by 1,000. And then X equals 148.2. The anticipated total to be sprayed will be 148.2 ounces, which will be rounded to simply 148. To determine the amount of herbicide needed to be mixed with water, we'll use the following formula and cross-multiply again. So 2 ounces per 1,000 square feet equals X ounces per 2,600 square feet. Therefore, we'll need to apply 5.2 ounces. Let's just call it 5 ounces of herbicide for this treatment. Remember to account for those 5 ounces by subtracting it from the total amount of spray solution needed to treat the entire lawn. Because we'll need 148 ounces of total spray solution for the lawn, we'll add the 5 ounces of herbicide to 143 ounces of water.
We all have different talents and skills. Some of you will be great at math, and so the information in this section will seem too basic. Others might appreciate the reminder of how to approach math story problems. I'm going to show you a way to sort through story problem information by separating it into information you already know and what you want to know in the end. Hopefully this strategy will be helpful and reduce the stress should you encounter story problems during a certification exam. Here's the first problem from the National Pesticide Applicator Certification Course Study Manual. The information in the 3 problems might not reflect the types of applications or areas in which you work, but the process of gathering and sorting through the information could be helpful. Here's the first story problem. You determined from a calibration test that your boom sprayer delivers 8 gallons of water over a 1/4 of an acre test area. You need to apply pesticide to a 10-acre field. How much spray mixture is needed for the 10-acre application area? Start by creating 2 columns. What do I already know? And what do I want to know? Now you can start sorting through the information in the paragraph. For example, you know that your boom sprayer delivers 8 gallons of water over a 1/4 of an acre test area. Now put that information in your first column under what you already know. Ultimately, you want to know how much spray mixture is needed for the 10-acre application area. Move that down to what do I want to know. Let's break it down a bit more by finding out how many gallons your sprayer will deliver for 1 acre, which will then make it very easy for us to determine how much is needed for a 10-acre area. You know your sprayer delivers 8 gallons for a 1/4 of an acre. We want to know how many 1/4s of an acre there are in 1 acre. There's 4, 1/4 of an acre in 1 acre. So we're going to multiply the 8 gallons by 4, and that will tell us that we need 32 gallons per acre. Since we know we need 32 gallons per acre, and we need to determine the number of gallons for 10 acres, we multiply 32 gallons by 10, and that will give us 320. Therefore, you'll need 320 gallons for that application area. See, it's easy. We've got 1 problem down and 2 more to go. Story problem number 2. From your calibration test, you determine that your backpack sprayer delivers 0.25 gallons of water to cover a 250 square foot test area. The label recommends applying pesticide at a rate of 6 ounces of product per gallon. How many ounces of product are needed to cover a 1,000 square foot application area? So what do we already know? We know the sprayer delivers 0.25 or a quarter of a gallon of water to cover a 250 square foot test area. And we also know the label recommends applying pesticide at a rate of 6 ounces of product per gallon. We want to know how many ounces of product are needed to cover a 1,000 square foot application area. Let's compare the size of the area we know to the area we want to treat. We know the amount it takes to cover a 250 square foot area, but we want to cover 1,000 square feet. So how many times does 250 go into 1,000? 4 times. Here's a quick review to tie all of our information together. How many times does 250 square feet go into 1,000 square feet? 4 times. Our sprayer delivers 0.25 or a quarter of a gallon of water to cover 250 square feet. Since we multiplied 250 by 4 to get 1,000, we'll do the same thing with our gallons of water. Therefore, we're multiplying 0.25 by 4. So that means we need a gallon to cover 1,000 square feet. So now we know it takes 1 gallon to cover 1,000 square feet. And the label recommends applying pesticide at a rate of 6 ounces of product per 1 gallon. You know you need 1 gallon. So this is where people start to get doubts because the next part seems too easy. 6 ounces times 1 gallon equals 6 ounces. We've got 2 down and 1 more problem to go. Now for the last problem. You've calibrated your equipment to spray 50 gallons per acre. You need to spray 1 acre. The label calls for 3 pounds of formulation per 100 gallons of water. So how much formulation should you add to the tank in order to make 50 gallons of finished spray? Let's begin with the same process. You've calibrated your equipment to spray 50 gallons per acre. This is the first thing that we already know. The second thing that we already know is that we need to spray 1 acre. Next, we know that the label calls for 3 pounds of formulation per 100 gallons of water. Now let's see, what do we want to know? We want to find out how much formulation you should add to the tank to make 50 gallons of finished spray. Here's a recap to help us break it down and get closer to the answer to our question. You know your equipment will spray 50 gallons per acre and you need to spray 1 acre. Therefore, you only need 50 gallons to spray 1 acre. Remember the label calls for 3 pounds of formulation per 100 gallons of water. But you only need half that amount, 50 gallons. Divide by 3 or multiply it by 0.5. And then you find you only need 1.5 pounds of formulation. We're all done. Here's some good news. There are several tools such as this online spray calculator tool from TJET to make life and calibration much easier.